Discriminant is part of the quadratic formula. We use it to figure out how many roots, zeros, or x-intercepts there are in a parabola. Okay? Now, in order to use the discriminant, I've given you variables b, a, and c. Those are in reference to the standard form of a quadratic equation. Okay? So we have y is equal to a x squared plus bx plus c. So we have our a. Whoa, there you go. We have our b and we have our c. The only way we can use the discriminant is if our equation is in standard form. So in other words, if we're not in standard form, we have to get to standard form. We'll have to expand and simplify either vertex or factored to get to this. The reason we use this, again, is to find out the amount of zeros or x-intercepts. So when we plug a b value, a and c, depending on what this is equal to, okay, will tell us how many roots there are. In other words, how many times this parabola is going to cross the x-intercept. If it is greater than 0, that means it's going to cross it twice. So in other words, we have a parabola, and we'll draw we'll do some small graphs here. If it has 2, what that means is it crosses it twice, so faces up and the vertex is below the x-axis, or the vertex is above the x-axis and it's facing downwards. These are examples that have 2 x-intercepts. If this value is equal to 0, 1 x-intercept means that the vertex is directly on the x-axis. So it only touches it once. Okay? And finally, if we have a number that is less than 0, that means we have no roots. And what they mean by no roots is there is still a parabola, but the vertex is either above the x-axis and facing upwards, or below the x-axis and facing downwards. Okay? So this will help us determine how many roots there are in an equation. So let's make up an equation here. Okay, who wants to make up the numbers? Okay.
6, 9, 22, 4.
Okay, 4. Yes. And what was the last one?
9.
9. Okay. Perfect. All right. So we're in standard form here. We have 6x squared plus 4x plus 9. We need to discover how many roots there are in this question. Okay. Now the quadratic formula. The discriminant is pulled out of the quadratic formula. Okay. And I'm going to show you. Because we use the quadratic formula, we've already learned that we use this to actually solve what the x-intercepts are. So, if, sorry, that's not a plus. So negative b plus or minus the square root of.
So, sir, that's the formula, negative b plus minus.
This is the quadratic formula.
Okay. b squared minus 4ac divided by
2a. Perfect. That's exactly the quadratic formula. Now, do you see the similarity here? Our discriminant is what part of this formula? Anyone know? The part underneath the square root. Okay? Now, the reason it's the part underneath the square root is because the square root is extremely important for us. For instance, if I were to get a value, and let's just refer back to our 3 options here. A value less than 0 means it's what? Positive or negative? Negative. Okay? If we're less than 0, we have to be negative. Therefore, if this value underneath the square root is negative, for instance, it's, let's say, negative 5. Can a square root negative 5? No. And in a quadratic formula, if we have a negative under the square root, we stop there. In other words, there are no x-intercepts. We can't find them. Okay? So we're just kind of quickening the formula to kind of figure this out. If the value is 0, so if we get 0 under the square root, what's the square root of 0? 0, that's one number. So whether I add or subtract 0, I'm going to get the same value for my x-intercepts. So I'll only have one x-intercept in that case. Okay? And finally, if we get a positive value, say we had, just for example, positive 9. Square root of positive 9 is plus 3 and negative 3. So there's 2 values there. That's when we would split our quadratic formula, and we'd end up with 2 x-intercepts. So that's the idea of the discriminant. It's just part of the quadratic formula. We're taking it out to decide whether there are 2 x-intercepts, 1 x-intercept, or 0. So let's go back to our question here.
So all you do is partial.
So like I said, let's use this standard form here. Hopefully hopefully we're already able to tell that this would be A, this would be B in standard form, and this would be C. If not, you got to go over standard form again. We put it into the discriminant. So our discriminant reading B squared minus 4AC. Well, our B is the number 4. Okay. We're going to square that and subtract 4 times our A value is 6, and our C value is 9. Okay. We'll just put a little equal sign on the side here. This becomes 16. Subtract 4 by 6. Anyone know? 24 by 9. 24 by 9. 18, 260. Okay, so when I subtract that, what do I get?
200.
Negative 200. I get a negative value. How many roots are there? Negative value. How many roots? How many x-intercepts? There are none. Because we wouldn't be able to square root negative 200, so there are 0 roots. Okay, you could say 0 roots. You could say 0 zeros. Or you could say 0 x-intercepts. All of these are acceptable, okay? Intercepts. Yeah, I know it's going slow. All right? I'm going to go through 2 other examples very quickly. Let's use 2x squared. So here's example 2. 2x squared.
And then 4?
Nope, minus 6 minus x minus 6. We're going to use these values and put them into the discriminant again. So our b value is negative 1. Yep. So negative 1 squared minus 4 times a is 2, and times c is negative 6. Negative 1 squared is 1. Negative 4 times 2 is negative 8. Negative 8 times 6 is positive 48. 48 plus 1 is 49. This is a positive value. So how many roots are there? 2. We only have the options of 0, 1, and 2. If it's positive, that means there are 2 roots. Okay? And the last example. We'll use x squared minus 10x plus 25. Okay? Remember, these are already in standard form. In some of your questions, you may have to convert them to standard form, just as a heads up. So our b value here is negative 10 squared minus 4 times our a value is 1, and our c value is 25. Negative 10 squared is 100. Negative 4 times 1 is negative 4 times 25 is negative 100. This becomes 0. How many roots are there if the discriminant is equal to 0? There's 1 root. Okay? Very important to remember. There's 1 root. It means that the x-intercept, a vertex, is directly on the x-intercept. Okay? So all we're doing today is really practicing that, going through it and make sure it makes sense to us.